start recording. Hello, everyone, and welcome to Handmade Hero. This is the show where we code a complete game live on stream, and unfortunately, we finished what we were doing yesterday, which is always, it's good to finish things, but it means that we don't really know what we're doing today, right? We do not know what is the most appropriate thing for us to come back and do. So I don't know what's going to happen here. And so I'm going to have to see. I'm going to have to look at the list and see what we feel like doing. Because we have plenty of options. There's plenty of things to do. It's not like we're done by any stretch of the imagination. But there is the question of what do we actually want to do here. So we did some of these things. We got rid of the even scanline notation. And we got put in the sorting, which for some reason was not actually in here, it looks like. And so the question is how we want to proceed. This is our list of kind of everything we could do, right? Like this is the list of like everything that could be done in the game. I mean, it's not complete, I'm sure, but it just was us listing stuff as we thought of it. Like, hey, we want to do this and we need to do that. And so we have a bunch of different things we could do. One thing we can do is we can go back and finish our debug code because I'd like to get that finished at some point. We've got some small things here like debugging some audio stuff, flush the thread, that sort of stuff. And I really don't know what I want to do. So I think, you know, I do wonder if it may be time for us to try to get things into sort of a more shippable state, just in terms of like being able to clean up, because there's not that much left to do before we're gonna be basically before we're just making game stuff, right? Most of all these things are just game, you know, right in the actual game, and we're gonna be wanting to play around with the actual game all through everything that's basically on the other side of this, right? And so one thing that I do wonder is maybe if now's the time to just bite the bullet, go into the Win32 platform layer, add OpenGL support so that we can finally go through some compositing layer that Windows will actually get us a VSync on. So that we know that we're running at 60 frames a second, or 30 frames a second, our choice, and won't have to worry about timing and accuracy and stuff like that, where we can actually get a locked frame rate. Because I don't really want to be in a position where I'm going to be like making things in the game and testing them out and having to deal with a non-locked frame rate. Now that also probably means at some point here I should stop streaming off of this computer and start streaming off of a different computer, because I do have an HDMI capture card because we bought one to use with Handmade Con. And so at that point, that would be a nice thing to do too, because then we could actually be testing on a system that didn't have OBS jumping in and stealing stuff. So I don't know, I feel like maybe Win32 platform layer cleanup and having kind of a thing there that we could say we could send this to somebody and it would reasonably play the game. So like clean up the audio code a little, clean up the video code so it's at least going through OpenGL for just at least the final compositing, if not the whole renderer. Like we don't have to actually make the whole renderer go that way if we don't want to do that right now, but at least getting it so that we have a VSync. That maybe seems like a good idea to me. I don't know. So I may just do that. I may say that that's what we want to do. That just seems like an idea to me. So anyway, if we wanted to do that, here we are back in our Win32, and we wrote kind of some of the stuff that we might want here. I like that threading is still on there. Of course, we actually did that. I guess we don't ever update our to-do list. We just do stuff off them. And you know, there we go. And so this one right here, which is hardware acceleration, I'm basically saying like, you know, let's go ahead and move these guys up here and start taking a look at those. I'm trying to see if there's anything else here that's relevant. I don't know if asset loading path, I think we might consider that done too, because we're not really going to do anything more with that than what we already did, probably. I feel like. So yeah, maybe that's about right. Anyway, so yeah, I'm saying maybe we do some of this here. Just a thought. So let me give you a little bit of a background just so you can kind of understand what I would be about to do, since I think that's what I'm leaning towards doing. So see if you can cast your mind back, if you will, to the olden days when we were just 250 hours of programming back in the past. When we sat down to get ourselves something we could work with on Win32 so that we could write all the stuff we did, like the renderers and the audio system and the asset loading and all that stuff that we've written in between then and now. And you'll remember we get called in this function called WinMain. This is where our program starts up. And if you remember, what we do at some point after we kind of get ourselves set up here, and we did a thing with fading in and out, but we create a window, and that window is what we use to draw, right? So, you know, we've kind of got this weird fade thing happening now. I believe this was Midblow's fault. He was like, I want to fade in and out from the Windows desktop. I don't know why he wanted to, he just wanted to. So we've got this thing where you like fade in and out, like that, and I think you can even escape out. Yeah, so it fades in and out. It does both directions, right? So that's, you know, that's sort of a little extra sauce on top that we did. But in general, the only important part is, so we have, I guess the reason I mentioned that is because we have a window that basically does the in and out fade for us. That's a separate window that we use to just black out the screen. But the actual window we care about is this window right here. We create this window, and we then make it full screen. Right? So we make it the size of the whole screen. It's not set to visible, so it's invisible. It takes up the whole screen, but it's not visible. Later, we switch it to visible, and then we start doing blitz to it, and that's how we display our game. Okay? So what we need to do if we want to use OpenGL, or Direct3D for that matter, but either way, we have additional work that we need to do now. We need to be able to set up our window in a way that tells Windows we're going to be using the 3D hardware, right? And the first part of this is actually pretty simple, and that's just linking to, remember we did this thing here, we listed, here are the Windows services that we call, right? So remember what these guys were. These are not the kinds of libraries that you normally think of where the functions are actually in the libraries. These are called import libraries, and what they do is they allow us to call through to the Windows operating system services that we need. So user32.lib has the stuff like create window, so we need to ask the operating system for a window, that's in there. GDI32 has like the graphics things like get device caps and that sort of stuff would be in there, for example. And WinMM had we needed that for one specific thing, which was setting the clock, the timer resolution, for the Windows scheduler, right? So far that's all we've needed to use, and you'll notice nothing in there, or I should say, nothing in those three import libraries connects us with the part of the operating system that talks to the 3D graphics hardware. Now we're on top of Windows, so there's no way we can hand code this. We can't talk to the graphics hardware itself. Windows is the guy who's got the access to the hardware. We have to go through it. And so what we need to do is add one import library that's going to give it that to us. Now we could add DirectX, we could add OpenGL. I'm going to add OpenGL because it's the more cross-platform version of the two. So what we learn here on how to start it up in Windows is not going to help you anywhere else. But if we actually do our rendering through it, everything that we do there will apply on every platform that OpenGL works. So you can apply this on Mac and on Linux, which I think is a lot better for an instructional series. That seems like a much smarter way to go because it's something you could use no matter what platform you're on, not just this one. As you might have guessed from the sort of naming convention here, other than winmm.lib, OpenGL32.lib is actually the name of the library that you need if you want to link to call the 3D graphics hardware through OpenGL. If we compile with this, we'll see that we just get linked. Nothing happens, right? Nothing actually occurs of note yet because we haven't actually done anything. And so if I run the game, everything's still the same. The only difference, like I was saying before, literally the only difference there is now we have the ability to call the operating system functions that OpenGL has. And similarly, like we had to do this to bring in these things like direct sound and X input and so on, we have to include an OpenGL header and in this case, I believe it's gl.h, and there you go. So what that does is that brings in all the OpenGL functions that we might need. So now we can talk to OpenGL, just like we had to include things like windows.h to call the other platform APIs and xinput.h to call the xinput APIs. Now, there's obviously more than one way we could call it. If you remember, for xinput and direct sound, the way that we actually called those, at least I believe direct sound. Is that true for direct sound? Yeah. For xinput and direct sound, you'll notice we did late binding here. So what we did is, instead of linking to those import libraries directly, we manually called getProcAddress, right? And there's a very good reason for that. With xinput, for example, it may not be on the machine. So if we were to cold link to xinput as a library, like a .lib, when our executable loads, if xinput was not installed on that machine, we would fail to load. And we don't want to do that. OpenGL, on the other hand, has the nice property of having shipped with Windows since the beginning. Like Windows NT 351, the oldest branch back you can go for this strain of Windows. Remember, we're on the NT branch. We're not on the Windows 95, Windows 3.1. We're not on that branch. We're on the Windows 1.0 branch. That died with Windows ME. That was the last version of that type of Windows that shipped. So all the way back to the very first version, Windows 3.5.1 had OpenGL support in it. So it's totally safe to link with OpenGL and use the basic OpenGL functions. Now, you can't guarantee that all of the OpenGL functions in the most modern OpenGL will be there, because that depends on how new the graphics card and how new the drivers are. So it doesn't mean you can just call any old thing in OpenGL that you want, because there are lots of extensions to OpenGLs over the years. There's OpenGL 1.0, 2.0, 3.0, 4.0, and so on, 4.3, whatever, right? So when I say that it's been there through the beginning, I mean the basic OpenGL 1.2 support, probably, or it might have been 1.1 support. I don't remember what the first version was. Might even be just 1.0, I don't know. But the basic stuff is all in there. So the stuff that we need to do to set up OpenGL in its limited form, for example, just to do like a blit to the screen, which is all we will probably do at first, that stuff we can always just call. Other things, and you'll see this if we decide to move the renderer over sooner rather than later, other things require a more sensitive approach. If we want to call the more advanced features of OpenGL, we have to take a more approach that is a lot more like the dynamic loading approach that we took with these other ones here. So, all right, so there's our gl.h. And now what we need to do is we need to get us into a position where we can actually use the OpenGL stuff on our window. So if you remember how we did direct sound, right? I don't know if you recall how we did that. When we do direct sound, like there's this sort of initialization process, right? We had to load the library. I'm saying we don't need to do that for OpenGL. It's okay to hard bind to it because, like user32 and that sort of stuff, it's something that will always be there. So when our executable gets loaded and it looks for the operating system services, they will always be there. It's just a question of which version, but they'll always be there. And then we had to do this stuff like direct sound create and set cooperative level. This exact thing, if you remember how we did that, where we had to kind of go through these steps, that's exactly what we have to do to initialize OpenGL. Now, the process is so janky that I am probably not going to remember how to do it correctly. Now, you've seen me program Windows on the stream a lot, and I am remarkably successful in this series at not having messed up too many things in the Windows layer, right? Which is odd. Like, normally you have to go digging through lots of people's tutorial code, and I haven't had to do that yet. I think that's just because I've been programming Windows so long. I will be shocked, I tell you, if I can get through the full initialization of OpenGL, even vanilla, without having to resort to looking at some sample code. I'll be shocked, but who knows? And it's not because there's that many steps, it's just because the steps are bizarre. All right, so we're going to follow exactly that thing that we had before, just exactly like this, where we have essentially a Win32 init OpenGL, right? I'm just going to make a function here, and I'm not going to think too hard about it. Like I said, I'm just going to put them in here because we've got a lot of stuff in this file. I don't want it to mush it into anything and get lost in it. So I'm just going to just start by saying, all right, we've got a window, and I need this window to have an OpenGL thing attached to it. All right. So let's talk a little bit about the OpenGL model. So before I start that, and have to deal with the pain and suffering of trying to remember exactly how it goes, let's just talk about OpenGL on Windows. Okay, so OpenGL is a graphics API. It was defined as an attempt to make a public spec out of something called IrisGL, I believe is the case of it, or is it IrisGL? Basically, there was just a thing called essentially GL, was all it was called, from a company called Silicon Graphics. Now, if you don't know what Silicon Graphics was, you could be forgiven. They don't really exist anymore. But what they were was way back before anyone really was ever talking about even the concept that a personal computer, a home computer, would have 3D graphics acceleration, because that's just a fanciful dream back in the 80s, let's say, right? Silicon Graphics was a company that specialized in building hardware-accelerated 3D graphics. So what they did is they produced workstations, high-end workstations, very, very expensive, that had 3D acceleration hardware in them. And this hardware could do remarkable, amazing, never-before stuff that you could ever have dreamt on a PC, like filling a triangle with a solid color. And yeah, if you set yourself back that far, you know, there were a bunch of people, Evans and Sutherland, these people making hardware that did stuff like filling solid triangles at a fast rate. Remember, these are the old days. That was remarkable and difficult. And then as time progressed, they did more and more stuff, the texture mapping hardware and that sort of stuff. And really all of what we now think of as stuff that you plug into the GPU, you know, the extension slot that basically is only used for GPU now, right? The PCI Express, whatever. All of that stuff, NVIDIA, and went back when we had 3DFX and all of that stuff, most of it came out of this. Most of it is because of these guys. In fact, NVIDIA and 3DFX, the old 3DFX, one of the first, you know, one of the first add-on cards for PC. The first was actually by Silicon Graphics that I know about, but was by 3DFX, and NVIDIA, all XSGI guys, right? Silicon Graphics was SGI, Silicon Graphics Incorporated, I think is what it was. But and so they really, basically what they did is people at this company, you know, they saw that the future was probably going to be 3D on the PC because it was getting cheap enough now to do, and they left Silicon Graphics and they started making add-on cards, and hey, this company eventually went away. Because the add-on cards for PC became so powerful, there was no need to ever buy a dedicated workstation because these things were just as good and eventually better, right? So anyway, what OpenGL was it was their graphics API. They had a graphics API that you used to talk to the Silicon Graphics hardware, the workstations. It was called GL, I believe. I can't quite remember. And I think IrisGL was just a name that you would oftentimes use to it because the Iris was the name of one of their product lines, I believe, right? There were different names. There's the Onyx, the Iris. They were different names of the workstations. And so what happened was Silicon Graphics eventually, and I don't really know why, I'm not really familiar with the politics of this company. I don't know very much about what happened in those days. You'd have to ask someone who worked there. But they wanted to make a more open standard so that people would program to this graphics language. And then, you know, that would be good for them because that meant that any programs that were written to that, if you compiled them and ran them on a Silicon Graphics machine, they'd run really fast, right? Because they have hardware acceleration for all the stuff that's in this GL. And so what GL was a way of talking essentially to graphics hardware back then, and really all it was meant to do was draw like lines and solid triangles and eventually some texture mapping. That was it. There was absolutely no concept of shaders or compute or any of that stuff. That's all new stuff. That was never in the original. The original was just very, very basic stuff. Okay, so what happened with OpenGL is it bifurcated into two sort of halves, and for obvious reasons. When this becomes OpenGL, and they create a committee for maintaining the standard and they make it a standard, obviously now silicon graphics machines are not the only machines running GL. What that means is there needs to be sort of two halves to OpenGL, if you will, right? The platform-specific part and the platform-independent part, right? And when you refer to OpenGL, really this is the part you're talking about. And that's things like if you've ever seen stuff like a call to GL vertex 3F or something like this, or GL clear, right? The platform independent part is the part that's all the calls that you're used to seeing if you've ever read anything about OpenGL. If you haven't, that's okay. You don't need to know it. I'm going to be telling you anything that you need to know about it, but if you've seen it before, that's what the platform independent part is. The platform specific part is how you get OpenGL like up and running on your platform. And the reason this can't be automated is because who knows what you're trying to do with it. How many windows do you have in your app that need OpenGL support? Are you trying to blit to one of them or the other one of them? Does this platform even have the concept of a window? Who knows, right? So that's very specific to the platform. So what they decided to do here is just not specify it, right? So when you say OpenGL, you're really never talking about this because they never bothered to spec any of it. It's just left up to the implementation on any given platform to decide how you want to handle that, right? And the OpenGL committee does have sort of a way of issuing standards for different platforms for the platform-specific part if you want, and that does sort of happen in a separate way. But for the most part, the OpenGL part is this part, and this part is really up to the platform people how they end up speccing it out, how it tends to go, right? All right. So this, the non-OpenGL part, if you will, is the part we actually care about today. And the way that that works on Windows is they have a set of APIs that are prefixed with WGL for Windows GL. And there's a bunch of functions like WGL swap buffers, I think is one of them. Is it GL swap buffers or W? Let me just see. Yeah, it's WGL swap buffers, right? Am I wrong about that? Hello? Ah, so no, it's not. They did not prefix it. That's why I was trying to remember, and I was gonna say it looks wrong to me. I was like, I don't think it's there, and I guess it's not there. So swap buffers is not that way. I take it back. So it's more like a better example would be wiggle make current. That one I am sure of. They did prefix. I'm pretty sure almost all the time it's actually prefixed. But swap buffers is just anomalistic. So there you go. That's an example of one, right? Okay, so that's the part that we care about here. All right, so you remember, well, hope you remember from our Windows programming, there's a thing called a DC, right? A device context. And a device context is just like a handle, basically, or I shouldn't say a handle. It's a notion in Windows of the state of the graphics at that time. So it stores stuff like, oh, you know, what's the coordinate transform of the stuff I'm drawing now? What's the active pen color, you know, mode stuff like that, right? And so we had things called HDCs, which are handles to a DC, to one of these. And we would always pass those around, right? Remember, we'd say like, oh, we got to draw something, we got to get a handle to the DC that we're going to draw into, then we use it, and then we release the handle, right? We had a bunch of stuff like that. Well, OpenGL has a very equivalent concept. It's called an OpenGL. It's an OpenGL RC, I believe. OpenGL RC. Let me. Yeah, it's. I can't remember what that stands for. Is it a rendering context? Yeah, okay, so there it is, rendering context. I'm just like, I remembered it was RC, but I didn't remember. There's an OpenGL RC, and basically what happens is this OpenGL RC sort of sits on top of this. implementation-wise inside Windows, because who knows, right? I've never been privy to that code. But I mean conceptually to the user. So what has to happen is, once you have a device context, you need to piggyback an OpenGL rendering context on top of that. And once you have an OpenGL rendering context, then you can issue your OpenGL calls. Now there's a caveat. There's a caveat. In Windows, and I can just sort of show you this example here. Let's take fillRect, right? It's how we might clear a rectangle in Windows GDI, right? You'll notice fillRect takes as a first parameter a handle to the device context that you are trying to clear, right? You can see that. It's right there. So when I want to clear something in Windows, I say, okay, fillRect with a particular HDC, right? Whatever, my DC or something, right? And whatever I want to do. And then it knows whatever this is targeting, that's what gets filled. So that's on some window somewhere. And so it knows if there's two windows on the screen, and they both belong to me, and I say fillRect myDC, it knows that whichever one myDC points to, that's the window where the filling takes place, right? But what you will notice very quickly when you look at OpenGL, if we were to look at, say, for example, GLClear, which is the thing that clears a buffer in OpenGL. Again, don't need to know this. We'll get to it all later when it becomes relevant. You will notice that it takes no such thing. The only thing that you pass to GLClear is a bit field that says what you want cleared. The color buffer, the depth buffer, the accumulation buffer, the stencil buffer. So if you have two windows or two buffers, how do you know what to clear? And the answer is that the whole state of the GL is actually implicit to your thread. So you remember we had threads, right, in Windows? They're the things that can be executing all at the same time, right? If we have multiple cores, each one can be operating a different thread. So like, for example, when we had our background rendering or our background loading, those were on different threads, right? And then we have the main thread, which is doing most of the work. So a thread is a single unit of execution, right? That's happening on some core somewhere, or it's suspended, who knows? But it's, it's a state, right? Each thread has implicit to it an OpenGL RC. So anytime a thread issues an OpenGL call, it must have previously established which OpenGL RC it is talking about. And in fact, I already mentioned the call that does that, wiggle make current. Basically what wiggle make current does is it sets what the OpenGL RC is for your thread. So what we need to do in order to get our OpenGL up and running, even just in a rudimentary sense, so our first goal will be to just like clear the screen with OpenGL, right? That's all we're going to try to do. We'll clear the screen to some hideous pink so we know it worked. So in order to do that with OpenGL, what we need to be able to do is we need to be able to create one of these OpenGL rendering contexts. And then after we do that, we need to be able to establish that it is the one for the thread, whichever thread in the system we want. It's the one for that thread that will display it to the screen. So whoever's doing the OpenGL calls, that thread has to establish it as its context. So hopefully that makes some sense. Again, not too complicated. It's basically setting up a tiered system. We have Windows's DC idea, and now we're essentially putting something on top of that, which is this OpenGL RC. Okay. So yeah, we start out, as you might expect, with wiggle create context is a call that will allow us to make one of these OpenGL rendering contexts, and you can kind of see there. So HGLRC is Windows term for an OpenGL rendering context handle, right? Handle to a GLRC. And so that's exactly what we need. So this is our OpenGL RC. We need to do a wiggle create context. And then you can see right here that we have to pass it that HDC that it's sitting on top of, right? So we need to do a get DC from the window potentially that we're calling to. We need to get that DC, and I believe I can release the DC. I don't think we ever need to hold on to it. We just need it temporarily so it can be associated with the window. I believe that's true. We'll find out in a second. Like I said, hard to remember all these things, but... So we get the DC, we create a context off of that DC, and then we would need to make it so that this thread actually has that context sort of active, right? So we do a wiggle make current, and again, that wiggle make current is just to associate it with the thread, because just the act of creating it, it doesn't know whether you actually want to use that one or if you're just trying to create one to have it, and maybe you're creating multiple or something, right? So that takes the DC and the RC. Okay? So this obviously has a Boolean that it returns, so we expect this to be true. If it's not, we might want to go ahead and do a diagnostic here, but it's probably never going to fail. But we could, at the very least, right now, say, like, invalid code path. Right. So I'm going to compile that. And at this point, this would be, you know, success, in theory. Now, there's a caveat here, right? Because that looks way too simple, right? It's like, oh, Casey, you said this was going to be complicated. There's no way you were ever going to get it right. And yet that's so trivial. What could be easier than what you've just typed in? Well, I'm going to go ahead and go a little further maybe, just so we can maybe test this guy or whatever and show you that this doesn't work, because there's a bunch of stuff we actually have to do to make this work. So I wish it were that easy. It's not that easy. This call basically won't actually do what we want it to do, and we'll get into why that is a little bit later. So let me just finish up this quickly, and then you'll see. But if you're thinking in your head right now, what was he talking about? Trust me, it gets worse, if that makes sense. All right. So if we call win32 init OpenGL, then we will have an OpenGL context. Now what we need to do here is we need to actually do something where we'd actually be able to see it working. And so what I'm going to do is I'm going to take where we do all the rest of our stuff, like our swap buffers, sort of our stuff where we like present. So I believe we have our stretch. We have like a stretch GI bits, win32 display buffer and window, this thing, right? This win32 display buffer and window right now is taking that off-screen buffer that got drawn, and it's going ahead and it's putting it out to the screen. I'm going to go ahead and disable all of that right now. And so what happens if I run this is we should get, you know, our game should disappear. So we should have our fade, and there's just garbage or whatever, blackness, who knows what is there, right? So then I'm going to insert some OpenGL in here. Now this is very simple. The basis, the really easy part about this. I'm just going to set some things, and again, you don't have to pay too much attention to these, but I'll kind of go through what each of them are, and we'll cover them in more detail later when we actually do a render path with OpenGL. But I'm just going to sort of show you the 3 steps we need to show something on the screen. So first of all, we have GLClearColor, and what GLClearColor does is it establishes what color will be used for clearing the screen. And basically we just pass it. It's exactly like you've seen before in all the rest of the stuff we've done. It just passes a floating point value for red, green, blue, and alpha. That's the destination alpha channel. So in the frame buffer, remember we had in our frame buffer, we had a 32-bit frame buffer with 8 bits for alpha, red, green, blue, right? And we oftentimes talked about them and operated them on floats, but then we converted them down to 8-bit. The exact same thing is true for OpenGL. In the clear color, we can set what colors we want in a floating point sense. So we can say, oh, I want to set it to like purple, right? Or something like that, right? Maybe I'll set the alpha to 0. So I'll set it to like a bright, ugly, a nice, ugly, bright purple or something. And what that'll do is it says that's the color we're going to be clearing with. And then when I go to clear, it will automatically, one of the things about OpenGL is it's a little bit higher level. It's not that low level of a graphics API. I mean, it is low level, but it's not that low level. It's not like Mantle or something where it's, you know, trying to target a sort of a specific graphics card format, right? So OpenGL does some things for you. So for example, when we do GL clear, it doesn't matter what format the back buffer actually is that you're clearing. It'll automatically convert the color down to whatever that is and then fill it with that, right? So GL does do some stuff for you, if that makes sense. And that's some of the things it does. So that's that. And then we have the GL clear call. We just say what we want to clear. Now I would like to clear everything. Oops, that's not what I wanted to click. But the only thing we actually care about at the moment is the color buffer, because we're not really using any other buffers. We're not using any of these other buffers. So I can just say, hey, it's the GL color buffer bit. That just means clear the color buffer. If you have other buffers, we haven't talked about what any of these are, so you don't care, and neither do I at this point. But these are other buffers, like this. The depth buffer is a Z buffer, what we call a Z buffer, right? The accumulation buffer is an old OpenGL thing that you don't even use anymore. And the stencil buffer is a thing for very specific raster ops. There's tons of reasons why it exists, and we won't even go into them. I don't even know if we'll ever even talk about them in Handmade here. But point being, color buffer is the actual displayed colors that we want to show on the screen. And so here's some OpenGL that makes that happen. Okay, so we have GLClearColor that says the clear color. We have GLClear, which says the buffer bit. That does, much like we do, drawing to a off-screen buffer. So it's going to do those operations potentially on some memory that we can't actually see. And the way that you bring that into to actually display that to the window is you call swap buffers, which says, hey, go ahead and display whatever it was you were displaying. But in order to do that, I believe we have to give it the DC that we're trying to swap with, I think. Yeah, that's it. And so then we just say, okay, display that. Now, again, there's a little more business we probably want to do here, just to make sure things are just a little more correct. And that is, there's also a notion in OpenGL of what region of the screen that you're drawing to, right? And that is done with this function called GL viewport. And what GL viewport does is it just defines the boundaries of what you're trying to render, right? And so really, we just want to clear the whole screen. So we would just say, hey, you know what, guys? We're just going to go from 0, 0 to width height. And that's it. But that right there is roughly the correct GL for pick a region of the screen to render, set what color I want to clear it to, clear it, and we'll call that done for now, display it on the screen. Okay? Now again, we haven't gone into too much detail about exactly what happens with those, but that's the basic idea. All right, so now every time we go to display something, instead of doing the stuff we were doing before, it'll do that. However, unless I'm very much mistaken, this will not show us a pink screen. So you can see that we have no such pink screen to speak of. Why is that? Well, this is where it starts getting into the stuff where I was like, yeah, it's not as easy as you might like. First of all, well, I guess that's not fair. We have to at least call the function. So let me call the function, and then it still won't draw pink, and then I can say what I just said. So let's go down to where we want to put this. Once we create the window, obviously, then we'd be ready to initialize OpenGL on it. So let's go ahead and do that. Oh, hey, perfect, even better. So we don't even get past initialization. Presumably that's because we couldn't create the RC. Yes. So that's great. That illustrates it even better than not seeing pink. You can just see that it didn't work. So why didn't it work? Wouldn't it be great if it worked? Yes, but why didn't it work? Well, the reason it didn't work is because for reasons which nowadays I would say are very legacy. Back in the old days, there was a lot more optimization around things regarding graphics in terms of like the format of what was on screen and what was stored, because memory was very expensive. You didn't have infinity of it like you did now. Memory bandwidth was very expensive. You couldn't just go around having everything be 32-bit color all the time and all this stuff. And so in the old days, you used to have stuff like Windows could run in a palletized graphics mode, for example, right? Like Windows could run in an 8-bit color mode where there was a color table and each pixel was only 8 bits of data, and it could go and like look in a color table to see what color that 8 bits referred to, right? So it's a paletted, you know, like a color palette. I mean, heck, it used to run in a 16 color mode, right? And so when you were actually hooking these up in the old days, it was important to tell Windows before you actually tried to do OpenGL rendering to a window what kind of display you were actually trying to accomplish, what kind of pixels you were actually thinking you were gonna A, store in the back buffer for OpenGL, and B, display in the actual window itself. And so what you have to do is a thing called set pixel format. Now, if I remember correctly, we started about 15 minutes late, so I think I've got about 20 minutes. We might be able to get this done. We might not. So I think it's called set DC pixel for, yeah, there it is. So what you have to do here is you have to go through a ridiculous dance to figure out what quote-unquote pixel format you are going to set your DC to for OpenGL to use it for rendering. And you can see by this descriptor that it is not a fun thing to do. Basically what you're trying to do is set up all of the possible information you might need. Now, if you remember from when we did bitmaps, remember like green shift, red shift, that sort of stuff? Where we were talking about where, like what the mask was for where the bits were and what the shift was. Well, this is that times 10, right? Now you've got the RGBs and you've got the accumulation buffer and the depth and stencil buffers. These other buffers that I said we don't even really care about right now, all of that stuff has to be specified, right? But yes, it would be straightforward if all we had to do was fill one of these out, because then we just fill out whatever we wanted. We'd say, here's where we want the red, here's where we want the green, here's where we want the blue, go nuts. But that's not what this is. What this is actually a way of selecting from the formats that OpenGL and GDI currently support. Okay? So you have to imagine this more as like a negotiation process where we have something we want, which is a 32-bit RGBA buffer, right? And OpenGL, the graphics library and the card that it's running on can only support certain ways of dealing with pixels because it's hardware, it's graphics hardware, it's not completely arbitrary, right? So it's actually a negotiation. So we actually don't make one of these. What we do instead is we try to find one of these, right? And in order to find one of these, we need to use these other functions here, right? And so what these are, choose and describe, right, is describe pixel format will, if we go through all of the pixel formats, right, describe pixel format allows us to pass an index and say, what is pixel format 0, Mr. Operating System? And it will come back and say, oh, here is the pixel format descriptor for that thing, right? This giant mess of nightmare, okay? And furthermore, then we'd go, okay, what's pixel format 1? What's 2? What's 3, right? And we ask until, I believe, I don't even know if we can get how many there are. I think we just keep asking until there's no more left, right? Until it says I can't give you one. Is that true? Yeah, I'm pretty sure that's true. So basically, we just keep asking until it tells us that we couldn't get one. So we just ask, and we would get all the pixel formats that are there. And we'd see whether there was one that fit what we wanted, right? That's one way we could do it. The other way we can do it is to ask the operating system to try to find the pixel format it has that most closely matches something we pass in, right? And that's the one that I'm gonna choose because I seem to recall that that works fairly reliably, right? And so what we do is we fill out some small part of this, we ask it to pick the closest thing it can find, and then we hope it comes back with a yes that it found one. All right. You can see why I say that this is easy to forget how to do it right. So here is one of these things. these pixel format descriptors, what we need to do is we need to first set our DC to that. So here it is, pixel format descriptor, right? And we're just going to have, this is our pixel format. This is our desired pixel format, let's say. We initialize it to 0. We now have to set up the ones that it says that we need. So here's choose pixel format, and here's how we have to set it up. The n size is obviously the size of the data structure. This is that stupid thing that Windows does that's absolutely useless and has literally never helped them a single time, which is that you have to say how big the struct is so that, in case it gets like extended later or something like that, right? Then we have an n version, which this is the version number, because in case that wasn't enough. And of course, there's only ever been one version, and it's that one, right? There we go. We then have the flags. And for the flags, these we do need to set appropriately because we need to ask it to support OpenGL rendering. And here is that flag right there. As you can see, like I said, this was built into Windows. OpenGL was, despite the fact that Direct3D is their like thing that they push on everyone, OpenGL was the original graphics API built into Windows, 3D graphics API. Direct3D was a much later addition. So we need that, right? We need to be able to do OpenGL rendering. And we also need to be able to draw to a window, because we are not just compositing some back buffer that we're going to read. Like, because you can imagine starting up OpenGL or an HDC that was just for like rendering into a bitmap that you were going to like save to a file or something, and you never display it to a window, right? But we actually need that to happen, right? And furthermore, we want double buffering. We want our window to be able to draw to a back buffer and then present to the front buffer, right? So I believe we also want that specified. Okay, so that's what we need our pixel format to be. C color bits is 0 or greater. We want to have 32-bit color, right? That's what we're trying to display here. So we want 32 color bits. And then I think, let's see, not use 0 or greater. So then we have alpha bits. Oh, so I guess not. Color bits is probably not inclusive of alpha bits. So this is probably just 24. And then we want our alpha bits to be 8. We don't care about any of the rest of these. We don't need an accumulation buffer, a depth buffer, sample buffer, or an auxiliary buffer at all. We don't need any of the layer values. This is for doing stuff like overlays, which they supported in the old days back when hardware was slower, and they needed to do like overlays at hardware time and so that's not relevant at all. So we're just saying that we're just the main plane, the main graphics that's being displayed. That's a completely meaningless value at this point. And that, I think, is what we need, according to that piece of documentation anyway, is what it wants us to do, right? So we do our choose pixel format, like so, and choose pixel format takes the HDC and the pixel format descriptor that we're trying to match, and it returns us an integer that's which pixel format, right? So this is the like suggested pixel format index that it's going to give us back. It's what it thinks we should use. And so again, I guess I should put this up here because we need our DC. So it's the window DC, and we've got to pass the address pixel format. That, in theory, picks one for us. And then we have to set it up. So we have to then say, all right, set pixel format on the DC, the one that we got back, right? We need to set. So we say, OK, here's the window DC. I would like you to take the one that you told me that you wanted to use. I need you to use that one. But unfortunately, as you can see, we also have to point it to the pixel format specification. Now here's the problem. We don't know what the pixel format specification is, right? We don't know. It told us back at section 1, it might have nothing to do with the one we passed in. We have no idea. We just hope it had 24 and 8 in it, right? But we never gave it, we don't even have a fully formed one of these. We just have the half filled out one that it told us to pass it for this. So what we need to do in addition is make another pixel format descriptor here that's like the suggested pixel format. And that is one that we'll get from Windows itself and say, hey, that thing you just told me was the right one to use. Could you actually go ahead and describe it for me, right? And that's what describe pixel format does. So we pass in the DC that we're talking about. We take the integer that represents which pixel format it is, because again, these are just indexed in the operating system for this particular instantiation of OpenGL and I'm not OpenGL of GDI. So we just need to go ahead and say, okay, that one that you told us, whichever one that is, that's the one I want to hear about. We've got n bytes, and that says how big the thing that we're pointing at here is, right? And it won't write past that. And so then we just say, like, okay, obviously it's whatever the size of that. Oops, it's whatever the size of this was. Is how much you're allowed to write in there, and there you go. So we ask it to pick the pixel format that matches this for the most part. We ask it to describe the one that it picked. We then just turn around and hand that directly back to it and say, hey, why don't you go ahead and do that? All right. So that actually sets us up to be able to do OpenGL rendering, if that makes sense. Oops, forgot my ampersand. And like I said, I probably just am not remembering all the things that I have to do, so that may not be enough. But hey, that's some magic stuff you had to know by being a Windows programmer. How would you know that? Because you just know the magic of Windows. So here we go. Let's go ahead and step through this so you can kind of see, because I know that was just a bunch of randomness that I had to tell you just then. And there's really not a lot of rhyme or reason for it. So here's our desired pixel format. You can see that we didn't set anything other than the fact that we want 24-bit color plus an 8-bit alpha channel right there. And we have the version and the flag set, and then the size of the structure is 40. We then go ahead and say, hey, why don't you pick one for us? And that's going to give us back this suggested pixel format. At the moment, it's just going to say index 2, but as soon as we call describe pixel format, it should fill out this struct with whatever that pixel format was. So there it is. So the one we got has a bunch of random flags. Don't know what they are. We could try to test for them if we wanted to. Don't really care. The color bits is 32. So that suggests to me that maybe the alpha bits is included in here. So I'm going to go ahead and say that we actually should pass a 32 to that then. And is it documented? Maybe it's documented. Let's just double check. Does it say number of color bits in each buffer refer to be the size of the color buffer excluding the alpha bit planes? So do they just straight up not follow their own documentation? It kind of looks like that, doesn't it? It says excluding. I don't know what to make of that. It says right in it that it's excluding. Well, anyway, I'm going to go ahead and say to do, Casey, hey Raymond Chen, what's the deal here? Is C color bits actually supposed to exclude the alpha bits, like the docs, like MSDN says, or not? Because it's pretty clearly not doing that when we come back in here, so I don't know. But anyway, you can see that what happened when we actually did this is that we got back a 32-bit color thing, which is what we wanted. It's got RG, B, and A, like we wanted. But you'll notice that it also decided to just give us some free buffers. It gave us a 24-bit depth buffer and an 8-bit stencil buffer. It just gave them to us. And that's presumably because this hardware only knows how to do that, I guess. I don't know. Who knows why? That's what it chose, so that's what we got. So we got extra buffers. We don't care. We won't use them, but we have them. Okay. So then we say set pixel format. Oops. No, we don't, because I actually added some code there. All right, so then we say set pixel format, which sets our window up to use it. And then we say wiggle make current. And hey, it actually works now, so that we actually have an OpenGL context, right? And hey, so I guess when I said that I was never going to get it right, I guess I actually did get it right. That was pure luck. It's been a long time since I've written any OpenGL startup code, but I guess we lucked out today. So anyway, that's OpenGL startup in a nutshell. That is basically all you really need to know about it. But there is one potential problem here that I guess I'm not sure if it's a problem or not. We could kind of see if it is or if it isn't. I guess I don't know. I'm guessing that the fade in, yeah. So the fade in does not work anymore. And that's not that surprising to me because OpenGL, I think, kind of just isn't going to listen to the on-top Windows stuff necessarily as much, would be my guess. Let me see. Yeah. So all the like overlay Windows stuff just stops working as soon as OpenGL is in the mix, right? So yeah, that fade in, fade out stuff, we will probably have to put the fade in if Miblo is still adamant about having the fade in part. That's going to have to be in the game proper, which is not a big deal, but just so you know, that's how that's going to have to roll. But that's it. That's how you start up OpenGL. And so once you've got that, you can now actually do just any OpenGL you want. There is one caveat, which is if you want to access OpenGL 3.0 or 4.0, you have to do an extended context creation call. So after you do create context, you then have to do a wiggle create context attrib call, which maybe we'll do a little later on if we decide we want to do OpenGL rendering. But that's the basics of getting it working. And once you do that, you can make any OpenGL calls that you want. So let's go ahead and go to the Q&A. Funny the pink didn't show up on the stream. OBS problem. Yeah, I guess it can't capture OpenGL. Connor Rents, we all just saw a black screen, not a pink screen. So I guess what I'll do is I'll switch over to using the capture card. Is probably what I'll do. And we'll just go from there. Cuber Caleb, according to this, you should use 32 for the color bit. Yeah, I mean, so as far as like, it looked pretty clear to me that the docs are just wrong. Because we looked at what came back, and it came back, we passed 24, it came back 32. So there ain't no such thing, and it was 32 with 8 bits of alpha, and there no graphics card is gonna prefer 32 bits of color plus 8 bits of alpha for a 40-bit color buffer. That's not a thing. I mean, it's not that you couldn't do it, but it's not going to be the thing that's going to default to, right? So I'm pretty sure that those docs are just wrong. Pretty sure. Gary Johansson, curious if the CPU or the GPU actually communicates the information to the screen. I feel you mentioned this. I forgot. So I'm not sure what you mean by information to the screen. I don't know exactly what that means in your mind. But what I will say is that what's happening at the moment is that the CPU is packaging up a buffer, essentially, of commands. And those commands are then transferred to the GPU over the PCI bus where it executes them. Within a reasonable amount of slop, that's what's going on. So the clearing does not happen on the CPU. The clear to pink actually happens on the GPU, but telling it, the CPU like packages up the commands to tell it to clear to pink, and then the GPU executes that. Right, is roughly what's happening. 1213 IC. What are your thoughts about Vulkan? Not a fan, but can't talk about it specifically because it's not out yet, I don't think. I have to wait till I can actually talk about it. SSS McGrath, if you're ever in the mood to do a straight up unrelated tutorial stream, IO completion ports would be great because I ain't reading about that. Star, star, star. Presumably that was a 4-letter word that was removed. Yeah, I mean, I got so much stuff to stream that I don't know that that's going to happen, but they're a good API. You should read about them. It's the one API in Windows that's actually good. What do you think of NVIDIA GeForce What do you think of NVIDIA GeForce does not clear memory? No idea what that means. Elvin, came in late. Do we have our own GL function pointers loaded now? No, not yet, because we are only using, at the moment, OpenGL 1.x, basically, because all we have to do to start rendering OpenGL is just use the ones that's actually built directly into Windows for always. But at some point, if we do, just putting our bitmap on the screen will not require any function pointers for OpenGL. But if we want to take advantage of like OpenGL 4.0 stuff or something, we would need, or 3.0 stuff, we would need function pointers. Insofar as tricolor other than pink, OBS might treat that as transparent. I think it's not going to capture. I think I could set it to capture. I'd have to set it to OpenGL capture or something, but I'm just going to put it through a capture card so we don't have to care anymore. That'll also get us out of the business of having this nonsense where there's always an 11% load on the CPU like all the time or whatever. /AC, do you know why they deprecate GL_alpha? What are you referring to? What GL alpha are you referring to? What API are you talking about? Novin, you don't need the describe pixel format call since when you use choose pixel format, it modifies your desired pixel format with the correct stuff. Oh, is that true? All right. I did not remember that at all. So you're saying that when I do this, it will just open... Wait, why did it not want to... Why was it not setting my breakpoint? Here we go. So you're saying when I do this, it will overwrite this for me? Nope. That is not what it does. You can see that that is not true, right? Because there it is, and it ain't overwritten. Cuber Caleb, since we have a depth buffer, does the Z sort really matter anymore? Yes, absolutely. For two reasons. One's for transparency. You have to sort if you want transparent things to work properly. And two, because it'll be faster. Because we can draw front to back and use like an early Z or things like that. We can actually get speed improvement from that if we want. So there's two reasons why you might want to sort even if you use the Z buffer. We probably won't ever use the Z buffer. Also, you save a bunch of bandwidth. If you don't use the Z buffer, then it doesn't have to read or write from the Z buffer, which is a good savings too. But you know, we may turn the Z buffer on to get the early occlusion of Z buffer, which we would still sort for, blah blah blah. Novin, my bad. Looks like the OpenGL docs are lying to me again. Yeah, well, they do appear to be pretty inaccurate. We just found that out more than once, I guess. Icarus, going to be doing multiple GL versions or just the minimum for general WinXP machines? What versions are most of them even on anyway? I don't really know. My feeling on that is that, like... My feeling on that is that we should probably only do like we should just pick a reasonable version of OpenGL and use it, because we're a 2D game. We don't need a lot of extended stuff. I mean, we could even just get by with OpenGL 2.0, I think, probably in a lot of cases. So we'll see. We'll try to keep it as minimal as possible, because I just don't think we need very much. Snovin92, would there be any benefit of using the new version of OpenGL for a game like Handmade Hero? Yeah, I mean, we will probably want some shaders, right? So So we'd probably want at a minimum some shaders. Probably. I mean, we could get by without them, but you know, we may want some effects in there. Who knows? Mad EQUA, is there a difference when calling a function like GLClear on the OpenGL32.lib versus the one on the graphics driver DLL? They're the same thing. They're exactly the same thing. So again, I was trying to underscore this. So when you see .lib, it can mean one of two things. Okay, it can either be an import library, or it can actually be a code library, right? So when you think about like, oh, I'm linking with zlib or something, right? Well, that's a code library. That's like a bunch of code that somebody wrote that's like you know, it's like compression code, and I'm gonna link it into my game, right? OpenGL32.lib is not that kind of a lib. OpenGL32.lib is an import library. It's like user32 or something like that. So what's in there are just bind points to the operating system. So when you link to OpenGL32.lib, what you're actually calling through to is just the OpenGL ICD that's loaded at that time. That's what it's going to link you to. Now, sometimes there's an operating system step in between, but that's necessary. Like it's Windows needs to intercept the call and do something first before it dispatches to the driver, right? But that's all this is. So all OpenGL32.lib does is it gives you the bind points that call into the operating system services you need to either jump directly to the driver if it wants to do that, or if it wants to go through Windows first to Windows, then to the driver. Because Windows needs to like do some checking or ring transition or who knows what it wants to do, whatever it wants to do. Quetzalcoatl, since we are using OpenGL, will you be modifying our 2.5 DNIS or keeping the code as is? The code will be the same, it's just we'll have a hardware path at some point as well. Question, for choose pixel format, were we not supposed to specify iPixel type and set it to PFD type RGBA? That could be. We could have missed that one. Let's double check. Here's choose pixel format. Oh yeah, no, you're totally right. We probably just lucked out there because that might actually just be 0. Or it might be that it just defaults to that if you don't. Let's see. Yep, we just lucked out. It happens to be 0. Well, we could just keep relying on that, but it seems like a little cleaner to just put it in there. So let's just put it in there. Thanks for catching that. Like I said, it's actually, I guess, technically correct just not to do that because 0 is the one we want. So this clear will always get us the thing, but it's a little nicer just to show that we actually were obeying it, the spec, properly. Angus Holder, so by linking against OpenGL32.lib, we don't need to use getProc address at all with OpenGL. No, unfortunately that is not true. And the reason, like I sort of alluded to at the beginning, is that the version of OpenGL that was built into Windows directly in the old days was too old. And so if we were only going to use OpenGL 1.x, then yes, we would never have to call getProc address. Because just like user32, just like we didn't have to call getProc address for create window, right? And I mean, we covered all this before, but I'll just say it one more time. So in your code, right, when you are talking about what's going to happen in the code, you've got two different types of things that might happen. There's like, I'm going to call, you know, I'm going to call my function, right? Or that I'm going to call, create window. Okay? This one is in the operating system. This one is I defined it in myself. When I link my program and produce the executable, this goes away. This is gone, right? There's never even a remembrance, unless I save like debug information. There's never even a remembrance that there was something called my function. All that happens is it directly puts into the compiled executable a call to the relative address that this function was compiled at, like where in the code it was. So my function goes away and it becomes call something, right? But that is not what happens with create window. What happens with create window, and there's two different ways that this can actually work depending on how you set up the linker. Might even be more than two ways, but there's at least two ways. What happens with create window is slightly different. Yes, it does change into a call with an address here, but that call to an address actually goes to a location with nothing in it. It's like empty. And this location is stored in a table. It's stored in like a relocation table. Or I guess we call it, let's call it a dynamic link table. That's probably the best word for it. There's a dynamic link table, and this is part of your executable, right? That says, at this location, I was trying to call create window. And everywhere you call create window, right, it all gets replaced with calls to that one location. And then what happens is the dynamic link table goes and romps over that location with the actual address of where the operating system's create window call is mapped in your process space, which it does when you load. So when you load, it grabs all this stuff, right? Not this, because this it doesn't care about anymore. It loads that, it obviously loads this, the executable. It knows where the dynamic link table is, and it loads it, but it doesn't care about that so much. It loads this stuff, right, into memory. So here's my whole executable. Here's like that place that, here's this location in the executable. It loads this into memory. It has a dynamic link table, but it doesn't have to store it. It just has to apply it once. So it knows about this, but it hasn't cared about it yet. It then goes ahead and maps other things up in here, right? It maps like create window. The actual code for create window gets mapped into your process space. It then reads through your dynamic link table and goes, okay, where were these? Oh, right here was a call to create window. Update that call to call into here. So it romps over the code, the nothing, the like no ops that were there before, and it puts them out to create window. That's how that works. And I don't know the specifics. I haven't looked at it in a long time. It might be that they're smart and they store, like the dynamic link table is actually sort of built into this so that it stores it. I know you can do a thing called delay load, which will also put the code into here that actually loads the library that it needs so that you don't load libraries that you haven't called yet. There's a whole bunch of stuff like that too. So this is a, this is an approximation of what happens. It's not exactly what happens, and I'd have to go reread the specifics to remember for this particular operating system for Windows how that works. But that's what happens. So get proc address is just us doing that manually. And the reason that we do this manually, well, there's some other reasons we might do it manually, but the main reason we've done it on Handmade Hero is because we don't know that this thing might exist. So for create window, we can always let the dynamic link table handle it because create window is always there. You can't possibly run on a Windows machine that doesn't have create window. You could very easily run on a Windows machine that doesn't have X input. So I choose to call get proc address for X input because if it's not there, I don't want to fail. It's just gamepad support. You can play with the keyboard. So I don't want my app to not run just because X input isn't there. I know that's the trend nowadays is to just ship a giant redistributable and the game doesn't run on half the machines and who cares and run MSVC, redist and all that stuff. I don't want users to have to do that. I want users to be able to just run the executable and it works. And so what I try to do is anything that I think might not be there, that's when we call get proc address. Now for OpenGL, if we only wanted to use 1.x, we wouldn't have to use get proc address because everything's just in there. But if we want to call the functions that were added after OpenGL. So OpenGL 2.0 and up, which is most of the stuff that's in OpenGL nowadays. We do have to call getProcAddress. It's just you don't call getProcAddress. You call the OpenGL equivalent, which is wiggle getProcAddress. And that is the mechanism by which you query extensions to the Windows binding part. And then I believe there's also GL getProcAddress, which is how you query platform non-specific extensions. And these two we probably will have to use. 1213 LAC. Since you are complaining about Windows pretty often, why don't you use another operating system? I don't know how many times I'm going to have to do this. Guess it never gets old. Let's see here. The reason is that if you are a game programmer, you have to use Windows. 95% of all the games are on Windows. And there's really nothing you're going to be able to do about it. So until these numbers get up to like 70 or something combined, you're going to be on Windows. Mr. Slick 1015, do you think for the OS export you will need a wrapper written in Objective-C to use OpenGL and make a window? Yeah, I don't think it even has anything to do with OpenGL. I think nowadays, if you want a properly behaved app, I think you have to write the startup in Objective-C, I think. But I don't do a lot of Mac programming, so it's been a long time since I've programmed on a Mac. Gary Johansson, this is probably dumb, but what about offloading much of the computing we are doing onto the GPU using OpenCL, then not use OpenGL and keep things mostly as is? I'm not sure exactly what you're proposing. Are you saying running our software renderer through OpenCL? The reason is because that really just won't work. You can't. GPUs run general purpose code much slower than CPUs do. So you can't just like give something to OpenCL and expect it to go any faster. You have to have organized the code so that it takes, it basically takes warping seriously. It's got to be based on doing 32 wide operations and severely parallelizable and stuff. We could do that. I mean, we could do the work because we've already got our things broken up into a tiled rendering kind of a thing. So we could do some of that, but that's not a good idea because we'd just be making a bunch of work for ourselves. That same amount of work, we could just call OpenGL to do the rendering as a separate pipe, which is what makes more sense for us, certainly, to actually use OpenGL's rendering services. Caleb, over the break I wrote a program that generates OpenGL function pointer decorations and initialization by scanning CPP-H files to determine what needs to be added. Do you plan on doing something similar for HMH, or will you keep it simple? We'll be keeping it simple on Handmade Hero, certainly, but that is the sort of thing that I do normally, yes. How bad is an if statement in a shader? Depends on whether all pixels take the branch or not. And obviously on the graphics card, that's goes without saying. Vits38, have you ever programmed for a console? Yes, but they were older consoles. Well, I guess I programmed for the PlayStation 4 for a week this past November. But like the time when I was doing more console programming was like the Xbox, PlayStation 2 days. And the GameCube as well. Linux has Windows Vista beat. I think you're right. So 0.15% Windows Vista 64, 32. So 0.45% is Windows Vista. Nope. Linux can't quite do it. It can't quite do it. No single SKU of Windows, of Linux, I guess, can quite beat it. Wait, but what's going on? That doesn't add up to the same number. I I don't even know what this is saying. I guess there's a bunch that aren't in here. But yeah, if you count all Linuxes, it does beat out Vista. So that's good. You are correct. Let's see. Let's see. All right. Well, that's about it for Handmade Hero for this evening. So I'm going to go ahead and wind it down. All right, everyone. Thank you for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. Now we've got OpenGL running. Who knows what will happen next? That was smoother, I think, than I probably expected it, but sometimes you get lucky. If you would like to follow along with our OpenGL exploits, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can follow along. We also have a forum site you can go to ask questions. We have a Patreon page where you can go to support the video series, and a tweet bot where you can find out when we're going to be live. And the next time we're going to be live is 5 p.m. Pacific Standard Time tomorrow, when we are going to go ahead and, I guess, display our frames through OpenGL. And then we can have VSync, which I wanted. But before we do that, I'm going to have to remember, so that you don't have to take the word for it, I'm going to have to remember to start going through a video capture card. So I got to find out where the video capture card even is. So I'm going to go do that. And I hope the rest of you have a pleasant evening. And I'll see you back here tomorrow. Till then, have fun programming. I'll see you guys on the internet. Take it easy, everyone.